the magical Thiago De Faria.
Hey. Make sure it's working. Yep. So, welcome everyone. For the people that are like trigger about the title, and it's a mouthful and it's confusing at some point, but I started back in the days as a mathematician doing predictions, and then I realized that 90% of my time I was doing SQL queries. So I started to go back and back to model data, then database administrator, sysadmin, network stuff I even did, and then all the AI thing that I studied in college with neural networks. These things were available now. Back in the 10 years ago, everything of this was a dream. So I started to transition a little bit more back into it, and with the knowledge that I had as being sysadmin and all the regular stuff that now are called DevOps engineers at some places, I decided, okay, let's try to bring all these features and all this knowledge that people have about building continuous delivery pipelines and blameless culture and postmortem and CI/CD, and see how can I apply that to data scientists that are sometimes separated from IT departments depending on the company. They work for marketing or for finance, they have their models, they work in their Jupyter notebooks, and how they can make sure that their time to market can be as fast as possible using some of the principles that north our DevOps initiatives. And just one heads up, I also organize a DevOps Days Amsterdam for some time, and I'm with Ken and with Matt and with all the people that, yeah, DevOps engineers is just the way that the market is, but well, move on. So something that I learned from Matt back in the days is that you always have to try to bring the audience in and make something cute for them. So this is my daughter. And she has a leg, you see? She falls and then she laughs. But anyhow, about the DevOps thing and the AI part. This is a tweet that happened in May. And when people say, I'm going to implement a DevOps team on my company, yeah, then you have to have a DevOps team and a DevOps ops, and then you have to have the DevOps ops, and yeah, you can go in this eternal flow that you don't know where it's there. Because in the end, DevOps is this combination of practice, of knowledge, of culture and sharing that has a lot to do with the automation and the measurement part, and then we go with the CAMs. But in the end, it's a combination of practice that wants to improve your flow, that wants to improve your continuous learning. And going from the idea back in the days when you have the beginning of the DevOps and you have the DevOps handbook and all this stuff, it always started to avoid this inherent conflict that we all had working in IT. And that was Dev versus Ops. The meme where people hand over something over the wall of confusion and all this stuff. This is where the movement started. And in every IT organization, this happened or it still happens. And it's this downward spiral that development wants to continues to build new features and bring more money because they're closer to the business at some point. And then IT operations has to maintain their stuff and InfoSec and all this thing. So they try to avoid new features to come unless we have email from the CISO or something like that. And you always have this confront, this battle between these two entities. But this will result, and what in the DevOps handbooks they call the downward spiral, that is something that things stop to going fast, you stop to develop new features, then the business side has to start over-promising things, because you didn't deliver, and then by over-promising, we as software engineers have to start cutting corners to go into that position. We start to generate a lot of technical debt, and by doing that, we give a lot of problems to whoever is downstream. And then we have the problems with people being on call, people start to get sad, they leave the company, and then you go someplace else and you say, yes, now I'm going to do things right. And then you start the cycle all over again. But we have felt that this time to market is one of the biggest problems, and we are kind of solving it with the culture and the sharing and the DevOps, and of course the toolings that are not, DevOps is not the tools, but we are solving with some toolings that before I mentioned and with the culture. And we found there was peace in the galaxy, right? But then we did this. We put product and development together with IT Ops, with Q&A, with InfoSec. Well, InfoSec depending, DevSecOps is here. But we did it. It's an ongoing practice. But at any point, data scientists were involved on this figure, on this picture. And there is no blame here. There's no fault in anyone. Because now we are in the season that AI is the hype. Everybody's talking that they're doing AI, that they want to do AI, their company's doing AI, 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 AI. And I'm consulting in the Netherlands, an engineer consulting, and usually when I go into companies, they want to do something related to machine learning and to AI. And usually conversation starts sometime with marketing or with finance, and I've heard similar things like this so many times. Google AI makes phone calls. Can you do something like that using that TensorFlow? Would really help us get more funding, or more political power in the company, or more this or more that. Sometimes it's not even attached to a business problem. And yeah, this is a person A that I talk, sometimes the VP of product, and then someone else in that same meeting raises, because they read a Medium article about something, and they talk, wait, can you also do it in a container using blockchain? So we are not just in an AI hype. We are in an over-information era that people have Medium profiles and Medium publications talking about a lot of stuff all the time. And sometimes the managers and the people connected to the business just fetch some buzzwords and start to put things around to try to get more political power, funding, or whatever they want. So this person B now is the VP of product. That other person was just not thinking about blockchain. But then someone else in that same meeting, sometimes, well, they did more than reading Medium articles. They went to a Gartner conference. They know everything that is going to happen in the future. So they pop up with this. We'll create an AI DevOps cloud-native application on Kubernetes using blockchain that the user will experience with a VR headset, and this will be our digital transformation disruptive strategy. So you put all the buzzwords all there, but AI is there, of course, and this is what I work. And now this person is there on this meeting, and somehow VCs heard about this. They just stormed their way into the meeting room like some James Bond movie. They crash everything, and they appoint that person the new CEO. They move him to the Bay Area, they get him funding, and now he's a startup AI CEO. Because this is how the board has now, a lot of money to invest in stuff. Because yeah, the crisis was so long ago. Who remembers about money issues? So we are here, we're there, and my job is to try to help this company go this in a scalable way and help the data scientists usually and the machine learning engineers to work in a way that people won't be pulled back. And I say that because I've been doing this in the Netherlands for the last 3 years, and I know a lot of companies that have data science, machine learning engineers, that their models can take 2 months to go into production, 6 months, 8 months, even 18 months I've seen companies. So what is the use for data science to deploy a model to production after 18 months? And then my question to you here now is, who here has deployed or has something on their company that has a machine learning component, and that is not an API call to Google or to AWS or to something? 1, 2, 3, 4, yeah. Some people have, but I guarantee you that in the future this is going to happen more and more often. You're going to have machine learning models going into production to be an API endpoint for someone. And you're usually going to be talking to people that are not on the DevOps team, in the development team, on the operations team. They're going to be on the marketing department, on the finance department. And we need to onboard these people into the movement says. DevOps is not, again, just dev and ops. It's a company thing. It's bringing business closer to IT. And to avoid problems, let's set a baseline here. What is AI? There are many definitions, many people talk about it. As soon as we talk about serverless as well, many people are going to mention different definitions of serverless stuff. So I'm going to share my definition of AI, just so you know. You may not agree with it, but that's what I'm talking about when I'm talking about AI. It's making computers capable of doing things that when done by a human would be thought to require intelligence. Simple as that for me, that is what AI is. So, what the hell is machine learning? Why sometimes they talk like the same? Machine learning is something encompassed underneath it, and that's, again, my definition. Make machines find patterns, without explicitly programming them to do so. And you do that because it wouldn't fit on if-else loops or clauses or stuff. You do that based on mathematical approximations to based on the data, statistical chances, things like that. But you input data, you put an algorithm, you fine-tune the algorithm, you put some hyperparameters, and you get something back. But in the end, surprise, surprise, this is not the whole picture anymore. You have data science and machine learning as well, close to the product, having to hand over something to you. And you don't want machine learning engineers and data science to work on a Python notebook, find something, and then give to production, say, hey, put this there on the cloud, because I did this on my local computer. This doesn't scale. Because you're all here. You're all here, you're all doing your best to improve. You're talking about Kubernetes, you're talking about Jenkins, you're building CI/CDs, you are increasing your soft skills, you're talking about empathy, you're making things better. You're treating infrastructure as a code, you deploy the pods, have microservices, you have everything done right, and then you receive a mail or a meeting from the CIO, the CTO of the company saying, hey, the priority now is pick up this Jupyter notebook and put into production as a REST API. And you're just there, how? Because, yeah, while you were rocking this, you are grading something good on the IT side, you are bringing value to the business, you are rocking the throughput, your flow is good, you're monitoring, you have metrics, you have telemetry. In the back, the data scientist is building a model that someone asked it to. And that model needs to see the day of light of day. I don't know, weird. Because how do they do this? The majority of the data science still do a lot of local development. And when I say local development, it's not Docker Compose or Kubernetes locally or anything. No, it's a Jupyter notebook running on their local computers. And they have this thing, usually, because they are PhD or master students or things, that they only want to show things to the business or to their coworkers when their job is successful for them. So they may spend sprints working in a model, and when they reach, I don't know, 80% of accuracy, then they will show something to the people. They will not commit all of that to a GitHub repository. They are not doing that step by step and interactively. They may even be doing sprints where their ticket is improve the model. There's no definition of ready, no definition of done, there's no story. They are doing sprints, waterfalling into stuff. And usually, they work with a lot of them, CSVs on a laptop. And these CSVs on a laptop is because your company has data warehouses, has different data sources. He's just trying out with things. He wants to find something that is going to be usable for the business. So he just do a SQL query at the data warehouse, join with something, pick it up some JSON files that comes from a Kafka stream, put them all together, do their own data munging on their local laptop, and they end with this CSV or these files that they're going to work on their local laptop. And then, woo, we're done something. Then they start building their model. And model building takes time. Usually, data science can do a good model, 70% of accuracy quite fast. But if you need to get to 98% of accuracy, wow, that takes a lot of time. But they do this. They get a good model, they find something, and then the end for a lot of data science and machine learning teams is, okay, now we're going to show to the CEO, to the CTO, or whoever the managing partner is. And they usually do this by having a PowerPoint presentation and a small demo showing their accuracy, confusion matrix, area under the curve. They show up stuff. The CEO is extremely happy about the way that things are going. And then they call a PR and they say, yes, we are an AI company now. And they do this by declaring, just like we do sometimes see companies declaring DevOps. Like, we implemented DevOps. We also see people, we are an AI company now. And then this person on top come to the IT department and just deploy this. But deploy what? Deploy a Jupyter notebook that is going to be accessed by whom, by when, by how? Are we talking about REST APIs? Are we talking about RPCs? How many requests per second are we going to get? How things are going to work out? Did you test this? So you receive this chunk of code, usually in Python, and you have no clue how to withstand the pressure of how this is going to run in production. Does this sound similar? So we have the part 2, the return of the AI. Now it's not IT versus dev. It's not ops versus dev. It's machine learning on one side, handing over things for the IT ops and the development and the QA and the InfoSec. And this is something that is very, very, very problematic, because I've seen a lot of problems happen on this handoff, and that's why I see companies that take 2 to 18 months to deploy a model into production. So I want to share some of the problems that I have seen in these companies, and some I may even have caused back in the days. This happens a lot on doing what you're good, what you're not good, and hire for. So usually you have very, very smart machine learning engineers and data scientists, and they hear about these things. They saw a presentation about Kubernetes, they did a few tutorials, they know a little bit about Jenkins, and they say, I'm going to build my own pipeline and my own data engineering thing, and yep, this is what I'm going to do in the future. So they are not good at that as much as you, sysadmin, you are not good at building a machine learning model. You need to learn, you need to work together. Because a lot of these companies that have DevOps, they still don't have implemented product teams. They still have the data science team inside marketing or finance and stuff. So create this team together and put them teams to do what they're good and hire for all together. So create product teams for these machine learning components that you're building. And that is other thing that happens a lot. Feature engineering won't easily scale. That means the part that I said about the CSV laptops, the person before runs the model and do all the training, he does a lot of transformations locally. He joins a Kafka stream with some SQL queries that he takes from the data warehouse and some data that is not in any database. He fetch it from like open data components that you can find and things like this. He put all of this, he trained the model, but now the business wants this model to run in real time. So how do you join all of this together and make this feature engineering, this building of the necessary components that you need on your model, if it comes from a SQL data warehousing, if it comes from JSON, if it comes from event stream, if it comes from Kafka, like how do you make all of this put together? So sometimes this feature engineering doesn't scale that well. And that's a lot related to this. The first request is, yeah, the finance team just want to run a model about this and that. So they fetch some CSVs and they start with, no, we just need to run this model every week. It's no big deal, nobody's gonna look into it. And then you take 1 year to get that into production, and now the requirement is like, no, this needs to be event-driven. This is real-time data we're talking about now. So the entire model that you build based on this batch approach, sometimes it's not simple to put in an event-driven way. And you also have something that is very, very counterintuitive for people that never work with machine learning. That is the model drift and the model fragility part. Everybody, when talks about machine learning and AI, a lot of people consider that this is, you have a model, you put into production, you never have to touch again. It's going to be continuously improving, right? This is the basic principle. Sorry to crash your dreams. This is not how machine learning works. We need to continuously iterate on the model, rechange it, recalibrate, add features, remove features, because models drift from reality. They are fragile to changes. You build a model, for example, that uses a feature that never changes. GDP, for example, it's one of the important things. Then, all of a sudden, Trump decides that the GDP of the US is going to be calculated in a different way from the other countries. How you're going to take that into account into your model? Or your data architect on the application side decided that one of his MySQL tables running on InnoDB or something, now I'm going to add a new table without the VAT or with the VAT. But I don't want to change the table structure, so I'm just going to add a new column and change my Hibernate to write to that new column. So you are there, standing with receiving nulls on a data point that was really, really important for your model. How can your model support this type of changes? And this usually comes with the part of the sharing and the culture thing, that this data science and machine learning should be a product and should be working together with everyone and be informed of every decision. I know this is a dream for everyone, but this is what we aim for. And the onboarding part, as I shared, machine learning engineers in data science usually a lot work alone, and they commit the final model to GitHub after 1 month of work or 2 months of work or whatever. So you don't see what all the models he used during this time. Maybe he tried 20 different types of algorithms and parameters, but he just publishes the last one. Then he goes to work for another company, someone else joins this team and say like, oh, I'm gonna try to use this model. Yeah, the other data science already did this, but he never committed. There is no knowledge sharing, there is no this. So onboarding new people into running projects that have machine learning components is usually extremely tricky. And you also have the part that is extremely hard to measure machine learning models. For example, you have a model that identify pictures or whatever. Let's say I take a picture of this and I want to see if there is a hot dog or not. How do I know if this is correct or not, if this is running on the mobile? You need to ask feedback for the user, but who here wants to give feedback for application if it's correct or not? You're just going to stop using it. So how do you measure if your model running in production is going well or not? You have to gather a lot of telemetry around everything and try to input some features and say like, yeah, I think this is not working well, because a lot of people, when they're using the hot dog or not hot dog app, after 2 tries, they don't use the app anymore. But then the business can come and say, this is just a stupid idea, but yeah, that's another thing. This has a lot to do with the culture change. We're talking about DevOps, and I'm talking about machine learning together with all these parts, and we need to help the culture in our companies to change. And this is something that I urge every one of you, when you start working on, again, on Monday, that you keep pushing for this. It's not because you're not on a C level that you cannot drive change. And also, the important things, the continuous delivery part. Machine learning is a component. It has to be something that you do something on your own machine, you push as a PR to any Git thing that you want, and that will stream on a pipeline. It's not different than any other software that you're building. These are functions that need to be put in a place, and we should strive for continuous delivery or continuous deployment, depending on the case, of all the machine learning components that you are building in your company. And to give you a little bit of idea, I'm going to do a small demo, and I hope the demo gods are kind. But let's try this. Stop to duplicate my displays. Okay. Here it is. View presentation mode. Okay, so this is a very simple Python code that just creates a regular logistic regression. And who here heard about Databricks? I think a lot of people know about Databricks. They are the company behind that created Spark. Spark is an open source project that is mainly used for this kind of things. And a lot of people on the community helped build this component called MLflow on the past 2 years almost, and it was released the version 0.1 recently. And what we do with MLflow is a way for data science to share their code, be able to serve their model, and be able to package their code in a simple way. So here we have the definition of the metrics that I want to evaluate my model. I have a main function on Python. I'm going to read some data. I like wine, so this is wine quality data, and I want to measure if the wine is good or not, based on some of the measurements of the wine. I create a train data set, test data set, and I input 2 parameters for this model of mine. So don't get too much into this. So the data science starts working into this, and he finishes code, and the ideal thing that we push to people is after they do this, they can, let's do it there. They can do a git init or something, push this code to a repository, you have things there, you have source control and things, but on the terminal itself, this person is able to, just starting my Python, and this person is able to, oh shit, cannot see this, right? Let's go here. So I'm start my environment with the correct package with the Python, so I don't have to screw it up any local Python stuff, but this is running on the cloud already. But I'm here, and then I just start my environment. I'm there. So if I do just run my model without anything, yeah, this is a new deprecated feature from Python, but anyhow, I get here all my measurements and all the values that were there. So my alpha and my ratio on the model, don't need to know of this, it's hyperparameters for this now, they are there. So if I do this, and now I do MLflow UI, of course, it's already running. If I run MLflow UI, I get this. This is a React application that connected to the Python package can send information about the runs that you did. So this tells me when did I run this model, which user run this model. Here on the version, you can see which GitHub repository was that, which commit of the GitHub repository was that, what are the parameters that I input into it, and what metrics did this get from. This makes things very, very scalable in the sense that you can have different users talking with the same GitHub repository, training different metrics, adding measurements, adding a lot of stuff, and sharing with people. Because now, you can come here and see, for example, this run here. Which command did I run? And this is a fun one. Now, if I commit this and I add one simple YAML file, I can run directly from any machine, just pointing to the Git repository. It will fetch the GitHub repository, package that, and run that in a Conda environment that is already on the YAML file. So if you push it, you can run from anywhere. So if you're running on Azure or anything, then people can just run your model there. And this is also very, very nice, because we are now talking about sharing knowledge, sharing the commits, sharing everything that we're doing, talking about packaging, but more than that, we're now talking about serving the model. And when I talk about serving the model, it's this. Just need to keep it here. MLflow, Scarlet Serve. So what I do here is, well, let's put it up, right? What I'm doing here is I'm serving MLflow. This is the basic package that used to this build. It serves this model. There is an artifact there on port 1234. So this is already running there. So now I can for example, test how can, let's say I have 20 data points to be able to receive a prediction from this model. Now I can simulate that, sending a curl, make it bigger. I can send a curl now. I can just send to port 1234 here the invocation with all the parameters that I have. And if I do this, I will receive the prediction from this. So now this runs as a RESTful API to be able to serve your things. So now I'm talking now about sharing and packaging and serving machine learning models that can be run into everything. And then we can think about requests. Where does this have to run? Do I need to load balance? Do I need everything? This is a regular HTTP. So that's what I had to share. I think the demo was a little bit rushed because, yeah, usually I do this in 1 hour. But thanks for coming in. I don't think I have time for questions, but thanks.